WoodBurner controller via a PID loop and a Netduino 2. This is the controller unit itself. What we have up here is a set temperature I want to keep it at, and the actual temperature that it's reading from, the PID values and the PID output, and just a current runtime. We have temperature up and temperature down. I won't hit them yet, we'll let it go, and then we're just reading some data out. What it's doing is using this box right here and reading the temperature from the inside. I have a little just a resistor in there that I'm running current through and getting nice heat out of it, that I'm then reading from this thermistor right here. Just a little thermo resistor, nothing too fancy. And back here we have the actual readings themselves on a nice little tablet. So the way it works, pretty basic. You just say temp up, it's 92. The box closed because it wanted to temp up, and we can watch the PID loop itself interact with that data, with the change in data I suppose, and recalibrate for the temperature. So it does it pretty quick. You can see the box is already open. I'll give you a full view of the whole system. It's 2 degrees. Doesn't take very long for the box to heat up. You see the PID loop in the background instantly take care of it. You can go down 2 degrees. For some reason, when it goes up degrees, it catches it perfectly, but when it goes down, the PID loop isn't taking care of it 100%. I'm not entirely sure why. No real big deal. But then, if you do something like blow on it, the box closes, reacting to me interacting with the system, and you see the little dip in the temperature right there. It's running at it's 10 Hertz, so it's nothing insanely fast, but more than capable of keeping the temperature within roughly 0.1 degrees. It sometimes fluctuates to 0.2 or 0.3, but in general it stays at 0.1 degrees. Then we have a bit of a control system. Flip this switch up when we're in control mode, and what it does is allow me to adjust the start of the box itself, just where the servo's 0 is basically. And that's because, I mean, the system could have all kinds of error if I had it up there or whatever. It's generic, but flip it back in, system goes in, see the box was closed and the temperature started rising, so it had to take care of it. While it's in the control loop, it will continue to calculate the PID variables, the temperature that's in the box. You know, the box is open too high, so the temperature is dropping quite rapidly. Turn it back on and the box will recalibrate. Fancy, huh? Not sure who made this little graphing tool. It works. It puts out some okay graphs, but it's kind of a pain in the ass to use. But so be it. This is a complete unit. This is actually going to control a wood burning stove, whereas it's the inverse operation. Whereas this box opens, it cools, and the box closes, it heats. We open up the damper and it lets air in. The wood gets hot because of air blowing across it, obviously, and then close the damper and it shuts the fire down. So it's the same basic concept, but then the inverse operation. And to achieve that inverse operation, it's literally just from the control unit. This is a 3-position switch. Go up to the control unit. It doesn't work very well with this because obviously it's backwards, and it'll never be able to maintain that temperature, but no big deal. Let me set it back. There it is. WoodBurner 2.0. I did the first one with the propeller microprocessor, but I was having some minor issues, more so irritation, without being able to debug code. So the Netduino was a easy, clear choice.